Hi, welcome to the next instalment of our Coventry University webinar series. My name's Craig Lashford and I'm the course director for the physical geography degree here at Coventry University. For those that saw our previous webinars, they're all available on YouTube, so please feel free to go and have a look. We've kind of mixed up how we're delivering them this time. So we're just going to do a short series of short release pre-recorded sessions, about 20 minutes to half an hour. These will be followed up by a kind of 20-minute Q&A, half an hour Q&A, based on some questions that you might have about some of the work that we've been doing. They will be released on the first Wednesday of every month and then followed up 2 weeks later. So my Q&A session will be at 5 p.m. on Wednesday the 20th of October. So I look forward to taking your questions. But today I'm going to be talking to you about sustainable cities of the future, managing flood risk in the urban environment. And then my Q&A in 2 weeks will be very much about answering whatever questions you've got on this topic. This session's really going to start to consider some of the flooding that we've seen, particularly our urban environments over the last few years. It's going to build upon my webinar that I've done previously, talking about climate change and urbanisation, but also that of Tom Lavers, who did his session on the 16th of May, all of which are available on YouTube, where he looked at rural flood risk and how we can start to change our watercourses or flow into our watercourses to reduce our flood risk away from the urban environments. And what this really means is it's about focusing on how our urban environments respond to rainfall. So in this simulation, you'll see that as the rain falls, it runs straight off because the surface is impermeable, it's tarmacked. We know that tarmac inhibits the infiltration and that engagement of the natural hydrological cycle. So what ends up happening is that rainfall falls on the slope, runs as surface runoff into the flatter areas and causes it to flood, causes that increase of all that water to rise and gather up or pool. However, in this next simulation, what you see is the slope is vegetated. We've got trees planted. At the end of the slope, you've got a grey area. That's to signify permeable paving. We'll talk more about what permeable paving is a bit later, but really it's a method of further engaging the above and below surface processes, so creating an opportunity or offering an opportunity for infiltration. You've also got a ditch or a pond, somewhere we can store and retain water. So in this scenario, when we see rainfall falling, it's intercepted by the trees and the vegetation on the slopes, but also we have that engagement of the subsurface processes, that infiltration, because there is no impermeable layer. Some water does still run off. It's a slope. We're going to get that. But then some of it will be captured in the permeable pavement system. So again, more infiltration. And that isn't is then captured and stored in the detention basin. And that's what we're going to be looking at today. How we can start to reimagine our urban landscapes to maybe move away from the use of these impermeable surfaces to trying to improve our flood resilience by using other methods. Things like this to try to really reduce our flood risk, particularly in the context of things we've just talked about with a changing climate and an ever increasing urbanising landscape. And we do this in our urban environment through things like sustainable drainage systems, trying to connect from our traditional drainage approaches that we've used previously, like pipe systems, trying to engage more with those natural processes that have been lost over time, particularly post-industrial revolution, with the removal of vegetation. Sustainable drainage systems are all about trying to increase infiltration, retain water, and try and utilize it in a much more effective way, which means that in a changing climate, we're able to adapt and deal with challenges that are posed to us by urbanization and by a changing climate with increasing likelihood of heavy rainfall events. And we know they work. So this is some research I've done previously, which starts to show how much you can reduce runoff just by simply using suds or some combination of suds. So for example, if we start to use swales, just green vegetated ditches, open channels, that's all they are, sometimes only as small as 1.5 meters wide, to convey and transport water around a site. But because they offer infiltration, because you will often line them with vegetation, that slows down the flow. And as soon as you start slowing down that flow, you decelerate the runoff. you're ensuring that as long as your site can do so and is capable of it, you are ensuring that more of that flow will infiltrate into those natural processes, which takes much longer to get back into your water source than what we would usually see, which are these traditional pipes, which get very quickly. If you recall my previous seminar where I talked about the efficiency of traditional pipe drainage systems, which bring together that peak flow and really reduce that lag time and really increase that peak. And we know that things like green roofs as well can be quite effective, capturing water on the roof of buildings and maybe reusing it for rainwater harvesting. I'll show you an example of that in a second. But it's really where we start to get into these things like PPS, permeable paving systems, or detention basins. When we start to bring those together, that's when we can really start to see our reductions in runoff. I've got here upwards of 70% for some of the big storms. This is a 1 in 100 year, 1% storm, up to 70%. Some of the research I did, which was using computer models to generate a plan of how much you could start to reduce. And this is all done through what we refer to as a management train approach. It's about trying to deal with water at lots of different stages. So you've got water at the source control, really as water falls, as water lands, starting to capture that runoff very quickly, and then conveying it to maybe some larger devices, things like ponds. So your source control might be something like at the base of a house, so permeable pavement, green roofs. It gets moved, conveyed potentially through pipes, but hopefully through a series of swales, open channels around your site to a much bigger pond. Then there's the possibility then at the much larger scale, the regional control, if it's necessary, having even bigger ponds. And it's all about keeping water above ground and trying to use it in different ways and starting to ensure that rather than very quickly flowing water out of your system through pipes, it's all about bringing it back with nature into those processes that the hydrological cycle defines that we should be using. So increasing interception, but also increasing our infiltration rates. And this video shows a really unrealistic volume of water that we wouldn't expect to see from a rainfall event being managed by this permeable block paving system. So there are little holes between each permeable paving block that allows water to infiltrate into the ground. So you can see really clearly where the gaps are to engage that water cycle. And an alternative at the source phase of a management train is a green roof. So this is the green roof on top of our Students' Union building at Coventry University, for those that have been to visit us already. Or those that know Coventry, you'll recognise the cathedral in the background. And this is a really key part of our university, or a central point of our university. But it acts, at the source control, dealing at the same phase or stage as a permeable paving device. However, whereas a permeable paving device really does deal with water on the ground as a replacement of tarmac surfaces, a green roof is replacing traditional tiled roofs on a roof. So whereas on a traditional tiled roof, that water will fall and then run straight off very quickly into the guttering system and then likely into the drains, a green roof is all about capturing that water through some kind of growing medium, through some kind of vegetation, and storing it through the soil system that you've got and that natural storage capacity you have with vegetation. And therefore either slowing that down and allowing it to drip feed back into that guttering system, but that happening over a much longer drawn out period of time, you're reducing that peak during high rainfall events. Or, as is the case with this example at Coventry, actually using that water for recycling. So actually a lot of the water in the hub is recycled. The hub is the building that we're talking about at Coventry. We recycle that water for things like flushing toilets. And the Hamilton site in Leicester provides an excellent example of actually understanding how SUDS can be incorporated in this management train approach. So it's situated in the northeast of Leicester. And you'll notice if you look at the time slider in the top left corner that this is what the site used to look like back in 1999. So completely fields. So no impermeable surfaces, just for farmland. However, if we fast forward to the modern day, we'll see that it's been developed to an astronomical level with 1,600 houses actually built on the site. And you can see these blue lines I've added in. These blue lines are how they've tried to manage the flood risk in this impermeable site. So there is little or no permeable pavement that's been used, or there are no green roofs actively on the site. However, they've used a series of integrated swales, so these vegetated channels that are engaged when there's high rainfall to navigate water through the site, essentially like an open channel pipe. Try and manage and reduce the flood risk, but there are also a series of ponds through the site as well that all try and reduce how much flooding there is and trying to counterbalance the increased runoff that we will see as a result of impermeable surfaces and as a result of the development that's occurred. And what ends up happening is it flows, if you can see to the very north of the site, you might just be able to see there is the Melton Brook. And all of this water is captured at the north end of the site. It slopes to that part, the north of the site, and it's captured up there and flows through a series of wetlands eventually into that Melton Brook. So what ends up happening is actually that all of these 1,600 houses that have been developed on farmland, their impact on the actual storm hydrograph is far less than it would be if things like this weren't incorporated. If it was simply using the traditional pipe system, if you look back at my Slowing the Flow webinar, you would notice a much greater, peakier storm hydrograph. And that's the benefit of integrating the system.
And this is what the system looks like. So we're now this is the Swale train, the SUD system in Hamilton, Leicester. It's about a few kilometres outside the city centre. And as I said earlier, 1,600 houses have been built on this whole site. And to try and reduce that flood risk, they've created this network of interlinked swales, which are quite heavily vegetated. You can see the thick vegetation to slow down that flow and really try and utilise this grassy verge, this grassy space. And behind, there's actually a pond as well, so that water backs straight through into it. And it's all about trying to reduce the flood risk. And this is possible when we're designing our sites, when it's a new build site. This is the kind of thing we can achieve if we integrate such processes at that design phase, and we can introduce this green infrastructure, vegetation to our sites to really slow down the flow, promote infiltration and try and re-engage the natural hydrological cycle.
However, whilst the example at Hamilton, as fantastic as it is, shows what is possible, obviously this is very different to our traditional existing urban landscape. So it shows what's possible at sites where we start to integrate or where we're redeveloping a site. So we can integrate and incorporate SUDs within that new development plan. However, that doesn't quite fit the same for our existing urban landscape. We can't just bulldoze our cities. We can't just completely flatten them. So we need to make small incremental changes. The vastness and the scale of the management train and the swale system at Hamilton isn't easily incorporated into our urban environment because it requires complete redesign of how our road network and how our pavements work. So to do this, we need to be a bit more creative with our opportunities. Things like large detention ponds, for example, are quite challenging because we don't have that space to put in a large pond, but also cost is a premium in an urban area as well. So it's much more profitable to spend money on housing or real estate than it actually is taking up quite a large amount of space to put in a pond. But there are things that have been done. So the Sustrain website has some great examples of what's been done in various parts of the world, particularly on what we refer to as retrofit design. And retrofit design is all about taking the existing landscape and trying to incorporate green infrastructure, trying to incorporate SUDs into it. So you've got this example of what we call a rain garden in Renfrew Gardens in London. So you can see here a small parked or grassed area that had already been there in the first place, and they've put a slight depression into it to allow water to run in. So it acts as a very small pond. You can plant some vegetation in. Well, that increases the potential for infiltration or just general filtration, particularly of pollutants. And it allows more of that engagement of the subsurface processes. Trying to incorporate things like green roofs is extremely difficult because you've got some of the challenges associated with reinforcement of buildings, because of obviously the extra weight bearing load that you would get from a green roof. And things like permeable pavement can work in some low traffic zones and particularly on public footpaths and car parks, but it's quite difficult on some of our major A roads because it doesn't quite have the durability at this stage to really work. But what we can also do is, if you see this bottom example in Llanelli, apologies for any Welsh speakers, my Welsh isn't obviously great, where they've put in here, where we would normally see grassed verges, and we see grassed verges alongside most of our pavements. We can actually incorporate those, put a small depression into them, and start to put little dams in place to slow the flow of water down through them. And this is a great example, again, from the Susdrain website, where we're starting to disconnect ever so slightly from the existing from the existing drainage network. Now, incorporating something like the rain garden or this Swales system network on our verges isn't going to completely manage our flood risk in the future. It's not going to be able to deal with all of our big events that the Met Office are predicting we will see, this increase of rainfall that we're likely to see as a result of the climate. However, if we can incorporate lots of these different measures around our towns and our cities and try and disconnect as much as possible from our urban existing drainage network, we're going to be doing something. We're going to be creating a much more resilient environment in the future, one that can withstand, if we do enough of this, some of the big events. But also one that looks better, one that incorporates green infrastructure. Greenery, as I said earlier, really does provide more than just a flood benefit. It's got the mental health and well-being benefits of seeing green space. It's got that water quality implication. We're going to improve the quality of our watercourses. Our watercourses have been hugely neglected in recent years in England, and a number of ours are failing their water quality standards. So by incorporating this into our urban environment, we can start to reconsider what they look like and provide some resilience in the future. But it is a big challenge because it is an expensive, potentially in the short term, cost to really redesign and rethink our urban landscapes. But that's exactly what they're trying to do in China. So I've done some research and I've been fortunate to go out to China before the pandemic. And I've done some work looking at some of the projects they're trying to incorporate over there. And they're reimagining their urban landscapes so they can try to be more resilient to changes in future climate. I think that the project is called the Sponge City approach. And it's all about reincorporating water above land and trying to increase infiltration. So the project involves 30 cities across China, huge money being thrown at this from the Chinese government. Cities have anywhere between 88 million US dollars to 59 million US dollars per city, that is. So, huge expenditures, far and above what we would likely see in this country. But it can create change. The likelihood is, and the plans are, they've got extremely ambitious plans to try to have 80% of all cities by 2030 to incorporate these sponge cities, what they refer to as modern drainage techniques. All about trying to reimagine and disconnect from that urban piped traditional network that we have and try and reduce the pressures that we put, not just on our piped network and drainage system, but on our urban landscapes and our fluvial systems, our river network, with the increased pressures from a changing climate, but also an urbanising environment. And these principles follow very much what we're trying to achieve through integrating SUDs. Things like infiltration, detention of water, so retaining water, storing it, which means that by detaining and storing water, we can slowly drip feed that back into the natural environment. It means we can cleanse our water, and it means that the water that hits our resulting watercourses eventually is in a far better state than it would be if it was just that polluted urban runoff. But we can also use that. We know that this has very much been focused on the flood possibility, but we know that there are going to be other challenges in a changing climate, particularly with the use of water. So if we can reuse it because of water scarcity issues, that's also a fantastic option as well that we can gain through integrating this idea of sponge cities. and draining it back through into that hydrological cycle. Now, this is an extremely expensive project, something that's cost the Chinese government a huge amount of money, but something they are trying and have been piloting for about 5 or 6 years now. And we've seen other countries try and adopt these methods as well, and really bringing green infrastructure back into the urban environment and trying to use SUDs to change how we've imagined our urban landscape. So to conclude, there are opportunities for us to reimagine our urban landscapes. We know that the pressures on the water system are only going to increase with climate change and urbanisation. So we are going to have to reimagine how we see our urban landscapes looking, and SUDs offer that opportunity. I wanted just to show you a few examples of what's possible, particularly if we're starting to redevelop our sites for what we can see at Hamilton. This is, however, extremely challenging, particularly in the retrofit environment, because it's very difficult to rip up our existing urban landscape. But if we can start to disconnect from our pipes and start to reuse natural hydrological processes, then we're going to start to see some benefits. And China have already started to do this on a much bigger scale by this sponge city plan, which shows what is possible and really what it's highly possible that future cities will start to look like in terms of how we manage and reuse and utilize our water. So thank you very much for your time. I'm going to be coming back for a Q&A in 2 weeks on the 20th of October. So please leave any questions for me, and I look forward to seeing you again soon. Thank you very much.